Hello everyone. Today I would like to give you a lesson on the topic exercises to test your knowledge. Today we will practice what we have learned and check how well we understand the material. These exercises are designed to challenge your knowledge, help you think critically, and apply the concepts in different situations. Let's get ready to test our skills and have some fun while learning. So, today I would like us to test our knowledge of the previous material with this exercise, and so, among the given statements, determine which ones are correct and which ones are incorrect. 1. There is a triangle whose midline is longer than one of its sides. Yes or no? I propose to construct one. I took such a triangle. I will draw a midline with green color and take some, it doesn't say which one, some side with blue color. What do we see? What do our eyes see? That the green line is longer than the blue one. So the answer is yes. Next, in the equilateral triangle, the shortest side is called a leg. Is this correct or not? Let's draw a right triangle. It have a leg, another leg, and a hypotenuse. And what do we see? What is being discussed here? The shortest side. The shortest side is, of course, this one, visually, and that's how it really is. The longest side is the hypotenuse. The shortest one is, of course, a leg. So here, yes, that's correct. Great. 3. There exists a triangle in which the angle bisector is equal to its median. Do you think this is true or not? Yes, such a triangle is simply isosceles. When you see the phrase there exists, you should run through in your mind whether such a triangle exists or not, and if it does, you should imagine it. Here, it is an isosceles triangle. In it, the bisector is not only a median, but also an altitude. The answer is yes. 4. The point of intersection of the angle bisectors of a triangle is equidistant from its vertices. Is this true or not? Let's consider an obtuse triangle and draw its angle bisectors. Here it is. I've drawn the bisectors in gray. Now, what was asked? Let's check equidistant from its vertices. So, I now draw the distance from this red point, the intersection point of the bisectors, to the first vertex. I marked this distance, this segment, in green. Then I take another one and mark it in blue. And what do we see? The green segment is not the same as the blue one. They are not equal. And then there's also the red one. But the statement says equidistant. In other words, the claim means that all these segments, the green, the blue, and the red, would always be equal. But no, right now we see that this is not the case. We have shown a triangle for which it does not work. Therefore, the answer is no. 5. The medians of a triangle intersect at one point, and the point of intersection divides them in half. False. False. They are divided in the ratio 2:1 counting from the vertex. Remember this. Do you see what a misleading statement this is? One could fall for it, look at it, and think, wow, what a nice claim. No, not a nice one. No, that's it. The answer is no. 6. There exists a triangle into which a circle cannot be inscribed. No, this is not true. Remember, a circle can always be circumscribed around any triangle, and a circle can always be inscribed in any triangle. Also recall that the center of the inscribed circle lies at the intersection of the angle bisectors, and the center of the circumscribed circle lies at the intersection of the perpendicular bisectors of the sides. That's it. Therefore, the answer is no. Congratulations on completing the revision of one of the sections of geometry, which is called Triangles and Their Elements. Of course, you will not be left without gifts. The gift is Volvo XC90.
And let's enjoy this wonderful music together.